Hello, in this video I'm going to demonstrate Potato, which is an explainable information extraction framework. All the components of Potato are open source and can be installed easily with pip. Potato can be used to automatically extract rules from provided examples by transforming them into a graph representation. Currently, Potato supports UD graphs, Forlan graphs, and AMR graphs. The supported languages are English and German. The extracted rules then can be used to perform interpretable classification tasks. In the README, you will find many examples for the functionalities of our framework. The backend of the application can be used as a separate package to build graphs and learning rules based on subgraph features. In the package, a human-in-the-loop web application is also included, and I'm going to discuss it in detail. In this figure, you can see the architecture of Potato. Potato consists of two separate packages. The UNLP is the package for graph transformation and subgraph matching. And then exPotato contains the machine learning algorithm to extract, rank, and evaluate features. The functionalities of these packages can be used separately from the human-in-the-loop interface or from the standalone REST API. All the components are under MIT license and can be easily installed. And this is the flowchart of the application. First, the framework can be started in the simple mode, where God label data is available and we want to build rule system on the task. The data can be prepared by the backend of the application. The simple mode needs the raw text, the label of the text, and the parsed graphs in PEMM format. The web application is built with Streamlit and can be started from the command line. In simple mode, both the training and the validation sets are needed as parameters to start the front end of the application. After loading, we can see the main page of the application. At the top of the page, we are able to inspect the dataset, and also we can see the parse graph for any sentence. In this example, we will use the Semeva relation extraction dataset. It is just a simple classification dataset to extract relationships between two entities. The running example will use the entity destination label. In the left column, we can see the first 5 suggested features by our system. We are also able to choose the class we want to build the rule system on. Features can be modified or deleted. New features can also be added anytime. After a first look, we can evaluate rules that seems like a good fit. After selecting them for evaluation, the results will be presented in the right column. We can see the precision, recall, F-score of each rule. The scores are reported on the training and on the validation datasets. Our system also enables debugging by the inspection of true positive, false negative samples of each rule. In the grid, we can select any of the samples to also view the parse graphs. The graphs are visualized and also the raw format is provided, so the users can copy parts of the graphs as new rules. One of the other core features of Potato is the smart suggestion system. If scroll to the bottom, the user can click on the Suggest New Rules button. Then a grid will appear with the offered rules. The user then can accept any of the rules they like based on any of the numbers provided. Then the accepted rules will be added to the rule list for further inspection. The user then can edit any of the rules to improve its accuracy. Then we can save the updates and re-evaluate the edited rule to see if it improved. In this case, we included a regular expression in place of one of the tokens, and if a regular expression is provided, Potato offers the user to refine the rule, selecting good candidates in place of the regular expression. Then we can evaluate the refined rule, so we can see that in the end it performed exceptionally well on both the training data and on the validation data also, only retrieving 1 false positives. The rules are always saved to the disk and can be reloaded anytime. The saved rules will be also in a tab-separated format. It contains 2 columns, the predicted label by the rule and the rule as a subgraph in a PEMM format. Next, after we are done building rules, we can use the saved rules to start the inference mode of our application for predictions. So this is the inference mode of the application. It can be started in the same way that the simple mode. In the left column, we have the loaded rules. We also have the same functionalities to edit, delete, or add new rules to the rule list. In the list, among the automatically suggested rules, we can find or manually added rules for the entity destination label. In the right column, we can type in any sentence to get the prediction. The sample sentence will be, I dumped entity 1 into entity 2. After running the prediction, we can see the parse graph, the returned label, and also the matched subgraph. In this case, the returned label will be entity destination. Also, besides the web application, saved rules can be used to start a Python REST API. First, we need to set some environmental variables, then the Python server can be started. After starting the server, any client can be used to make predictions with a given rule set. In this example, we used a simple curl request to retrieve the entity destination label for the sentence. The last mode of the framework is the advanced mode. In the advanced mode, God labels are not given in the dataset. As you can see in this test dataset, the label field is empty, but we can start the application this way using the advanced mode features. This is the look of the advanced mode. It is actually very similar to the simple mode. In the top of the page, we have the same dataset browser, but this time what is different is that the users can change or add annotation to the samples. Note that also partially annotated datasets can be loaded here, or we can annotate a few samples manually to get smart suggestions. Our other choice is to start building rules first. In the left column, we are able to build rules manually. Now I'm going to copy one of our entity destination rule from before to bootstrap examples. After clicking on an annotate based on selected button, we can check that the annotations have indeed changed. The users then can accept or decline any of the bootstrapped samples to make annotations. From the sidebar, we can start a training with the annotated samples. This way, we can get smart suggestions just as before. With these suggestions, we are able to make further bootstrapping, making this process iterative. Note that with this mode, we are building the rule set and the annotations in parallel. Thank you for being here with me. I hope you like our demonstration and you will make use of Potato. Please check our GitHub repositories for more information.